In 1990, the United States government passed legislation calling for a standardized emissions control onboard diagnostic system as part of its continuing effort to reduce automotive emissions. The legislation calls for this capability to be phased into new vehicle production, beginning with some 1994 models, and completed by the introduction of 1996 model cars and light trucks. This system is known as Onboard Diagnostics II, or simply OBD-II. As a Nissan technician, you already have experience with Nissan's ECCS onboard diagnostic system, and you're also familiar with using Consult to find malfunctions within ECCS. It's important to remember that OBD-II is not a change in the engine or automatic transmission management system, but an enhanced diagnostic function. This video will explain how OBD-II monitors functions of the vehicle's emissions-related systems and their components. You'll also see that with OBD-II, there are sensors used only for diagnosis of system functions. We'll explain OBD-II-related diagnostic trouble codes and how they are set. We'll show you how to use Consult to access information stored in the OBD-II memory. And next, we'll go through some examples of how you would use Consult to isolate malfunctions. Finally, we'll show you an example of a generic scan tool that can also be used for OBD-II-related checks. When we're through, you'll have a good basic understanding of this system. OBD-II checks components and functions in two ways. One is the concept of normality. Normality is when the system checks for open or short circuits. The second utilizes a concept we call rationality, in which components or groups of components can be checked for rational or predictable performance based on total input from all the related systems. OBD-II uses this type of check to monitor the efficiency of the catalytic converter and compare it to the expected performance parameters to identify deterioration. Similarly, it monitors NOx control by checking for the rational performance of the EGR flow rate. These methods are used to monitor and check the operation of the EGR and canister control solenoid valve to determine the effectiveness of the evaporative control system, or to recognize an improper engine coolant temperature sensor function, and to monitor the overall operation of the fuel injection, as well as the idle speed control airflow rate. OBD-II tests for an engine misfire, which from an emissions point of view is extremely critical. If a vehicle with a misfire continues to be driven, it could lead to a permanently damaged and therefore inoperative catalytic converter. OBD-II checks overall engine performance and, if a misfire occurs, can identify the individual cylinder by number. To make all these judgments on the emission system's operation, OBD-II requires some additional sensors. This input air temperature sensor helps achieve more temperature information for accurate diagnosis. A rear oxygen sensor is mounted downstream from the catalytic converter. A crankshaft position sensor, which is signaled by the starter ring gear teeth, is able to detect very small changes in crankshaft speed that can be used to detect engine misfire occurrences. The camshaft position sensor, which had previously been known as the crankshaft position sensor, remains unchanged and is responsible for ignition timing and fuel injection pulsing. Malfunctions in the automatic transmission will not only trigger codes in the Transmission Control Module, or TCM, but also in the Engine Control Module, or ECM, where they will be recorded as related to OBD-II. Problems will be signaled to the driver by illumination of the malfunction indicator lamp, or MIL. Remember, with the expanded functions of OBD-II, the MIL can be triggered not only by open sensor circuits, but also by sensors or systems which are not operating within their expected ranges. The ECM will store the first occurrence of a malfunction within the system, And in most cases, the MIL will not be triggered until the same malfunction has occurred on a second consecutive trip. A trip can be defined as lasting long enough to bring the engine up to normal operating temperature so that the system has achieved a fully functioning closed-loop mode, and that all sensors and other functions have been monitored by the ECM. One exception to the two-trip occurrence being necessary to trigger the MIL is a malfunction that would damage a catalytic converter to the point where it no longer operates up to emissions standards. In this case, the MIL will illuminate on a first trip. The MIL will start blinking under a severe circumstance, such as strong acceleration, that would be damaging to the converter. An integral part of OBD-II is an industry-wide standardization of diagnostic trouble codes, which are referred to as DTCs. The standardized codes are prefixed with the letter P and are the same for all vehicles. A listing of these codes can be found in the service manual. If a Nissan vehicle with the OBD-II system comes into your dealership with an illuminated MIL, you diagnose the problem much the same way as for any other vehicle. To isolate the malfunction, use Consult. Make certain the most current software is loaded into the Consult memory. Press Start, then touch Engine, then the down arrow, which brings you to the second Select Diagnostic Mode screen, and you find the Freeze Frame Data mode. This freeze frame data screen gives us the same malfunction information as the self-diagnosis results, with the exception of occurrence information. If there were no trouble codes detected, you would stop here. But our example has a code, so we have an arrow indicating additional data is available. Press the down arrow and pull up the freeze frame data. The information shown here was detected and stored at the instant of the first occurrence of this malfunction. The first system data item is fuel system data. This is the status of the fuel injection system at the instant a malfunction is detected. There are 4 modes, 2 through 5. For example, Mode 3 means the system was in open loop at the time the malfunction was detected. For a full explanation of these modes, look in the Consult Freeze Frame Data section of the service manual. The calculated load value is the airflow through the intake, expressed as a percentage of the total possible intake volume. The higher the percentage, the heavier the load. Next is coolant temperature data. Short-term fuel trim is a description of how the ECM is adjusting the air-fuel ratio for the short term, expressed as a rich or lean percentage. Long-term fuel trim is a description of how the ECM is adjusting the air-fuel ratio gradually over time, expressed as a rich or lean percentage of the ideal mixture. Then engine speed and vehicle speed. From the freeze frame data, you can determine the status of the fuel system, if the vehicle was stopped or in motion, and if the engine was fully warmed up to operating temperature. All taken from the first instant the malfunction was recorded. Let's look at an example of how to use Consult to diagnose and repair an emission system malfunction which was signaled by the MIL. To isolate the malfunction, connect Consult, touch Engine, then touch Self-Diagnostic Results. From the standardized DTC of P0420, we find the catalytic converter has deteriorated to a point where it no longer meets emission standards. To make this determination, the ECM compared data from the rear O2 sensor to that of the front O2 sensor. During normal operation, the voltage value for the front O2 sensor rapidly changes from negative to positive, indicating the front sensor is constantly adjusting the air-fuel ratio. If the catalytic converter is functioning properly, the voltage value of the rear O2 sensor should change slowly, which indicates the exhaust gases are being treated as they pass through the converter. These voltage change rates are called the switching frequencies. But the converter in question has deteriorated to a point where the voltage change rates of the rear O2 sensor approach those of the front O2 sensor. There's one important point to remember. The rear O2 sensor is used for diagnostics only. It has no influence on engine operation, and if it becomes inoperative, there will be no loss of performance or symptom of poor drivability. Here's another example of a problem you might see at your dealership. A customer pulled up to a stop sign when all of a sudden the vehicle started running rough, and the MIL came on. As the vehicle was accelerated, the MIL began blinking, and the customer then drove directly to the dealership, the light blinking all the way and the engine still running rough. After verifying the MIL was on, you connected Consult and found a DTC of P0301. This code indicated a misfire of cylinder number 1. For a cylinder misfire, the last digit indicates the number of the cylinder in question. If a vehicle with a misfire experiences only a light load, the MIL will illuminate steadily. But if the vehicle is driven under a load that is moderately heavy, the MIL will blink to indicate that this condition is very harmful to the catalytic converter. Let's go back to freeze frame and see what it looks like. Remember, freeze frame data is the information recorded at the first occurrence of the malfunction. With this example, that point is where the MIL went from on to blinking. The fuel system data indicates the status of the fuel injection system. In this example, Mode 3 means the engine was operating in open loop due to driving conditions. The calculated load value of 77% indicates the engine was under a moderately heavy load at the instant being recorded. The coolant temperature of 197 degrees was slightly high, indicating at least a moderately heavy load. The short-term and long-term fuel trims were both 100%, which under these accompanying conditions indicates the ECM is in a fail-safe condition. The engine speed of 3,950 RPM, along with the vehicle speed of 33 miles per hour and all the other data, indicates the car was being accelerated in a lower gear and under a fairly heavy load while the cylinder was misfiring. In this particular case, which was due to a defective spark plug, the MIL was triggered on the first trip and also began blinking rapidly as the vehicle was being driven under increasing load. As with any service procedure, it's always important to recheck the repair. In this case, after making the repair, use Consult to erase the DTC, then road test the vehicle again to check for any recurring or additional codes. In this section, we've dealt with the concept of checking for the malfunction of an entire operating system, rather than merely the normality of a single circuit or component. A part of the OBD-II regulation requires the availability of generic scan tools, or GSTs. The GST connects to the vehicle with a standard connector, which will be fitted to all vehicles that satisfy OBD-II requirements. Nissan vehicles which satisfy OBD-II will have both the Consult and the GST connectors. Each of these connectors is unique, and the GST will not connect to the Consult connector, and Consult will not connect to the GST connector. There are 5 diagnostic test modes for the GST. Mode 1 gives current emissions-related data values, including analog and digital inputs and outputs, and system status information. Mode 2 is freeze frame. Mode 3 allows access to the DTCs, which are related to the emission system and powertrain. Mode 4 gives O2 sensor test results. And Mode 5 allows clearing all the emissions-related diagnostic information. GSTs are designed to work with any vehicle, but as a Nissan technician, you already have access to a Consult unit at your dealership. Fitted with the most current software, it's your best choice for dealing with the requirements of OBD-II, and will perform all the necessary tests far better than anything else available. In this program, we've introduced you to ODB-II, a standardized system of onboard diagnostics designed to deal with emissions-related malfunctions. We've discussed the concepts of normality and rationality and how they help us identify emission system malfunctions. We've talked about the components and systems tested under ODB-II. We've explained the added engine monitoring sensors and their functions. And we've covered other points, including the operation of the malfunction indicator lamp and an overview of the diagnostic trouble codes. From a diagnostic standpoint, we've shown the key role played by Consult. We've gone through a couple of examples of the types of malfunctions and how Consult can be used to arrive at quick, accurate solutions. And we've covered some basics of the generic scan tool. Yet even with this technology, you should always refer to the appropriate manuals and bulletins for the details necessary to ensure complete repair. And remember, you still need to follow the normal and usual procedures, which are: verify the malfunction, isolate the systems and components involved, make the necessary repairs, and then check the repair and make sure there are no additional or new codes. We've presented this material on ODB-II and how it operates so that you'll be able to continue giving your valued customers the kind of professional service they've come to expect.